All right, this lesson is still talking about quadratic functions, and we're going to use the all three forms today. So we're going to jot them down real quick. So we'll start with standard form. So standard form is f of x equals ax squared plus bx plus c. And what we can tell from standard form is the y-intercept. And our y-intercept is c. So whatever number we have here, that's going to give us our y-intercept. All right. We also have vertex form, which is what we spent most of the day on the previous lesson talking about. Vertex form is f of x equals a, and then in parentheses, x minus h quantity squared plus k. And our vertex here is going to be hk. And then finally, we have intercept form or factored form, which is f of x equals a, and then x minus p times the quantity x minus q. And this one gives you the x-intercepts, and they're going to be p and q. All right. So on example 1, we're going to find the values of b and c. So f of x equals negative 8x squared plus bx plus c has a vertex of 2, negative 7. So I'm going to use the fact that the a is going to be the same in those two. So I'm going to rewrite it and have f of x equals negative 8. And then instead of it being in standard form, I'm going to write it in vertex form, where 2 is going to be h and negative 7 is going to be k. So it's going to be x minus 2 quantity squared minus 7. Right. Now that is this equation in vertex form, but we will need to put it back into standard form so we can figure out what b and c are. So I would go ahead and square the quantity x minus 2 using the shortcut I like to use. All right. Then I would distribute the negative 8. And combine my like terms at the end. Okay. So these two are the same function, just in different forms. So they have the same vertex, have the same intercepts, have all the same points. So to answer the question, we're looking for what b and c are. So once we get it in standard form, you can quickly see that b would be 32 and c is negative 39. Okay. Number 2 is way different. So we're going to write a quadratic function with x-intercepts of negative 3, 0, and 1, 0, and y-intercept of 0, 2. All right, so I'm going to start off using the intercept form or the factored form. So we do not know what a is. All right, the last question, that is, we knew a was. The rest of these we're not going to know what a is. So we're going to call it a. And then we'll go ahead and put in our intercepts in for p and for q. So because my factor form has a minus there, if my intercept is negative, it's going to be a plus. And if my intercept is positive, it's going to be a minus. And we all know if we take those factors, set them equal to 0, and solve, it is going to give us those two intercepts. All right, so now I just need to multiply all this out. Carefully. Okay, so this looks kind of crazy, but we can still figure it out. So now we have this in standard form. Even though we don't know what A is, we have it in standard form where I know that this should be equal to the y-intercept. So that's what I'll do. I'll just take it, negative 3a, and set it equal to the y-intercept. And so now I know that A is negative 2/3. Now we're not done, but we found everything really that we need. All right, so once we figure out what A is, we're going to take it and we're going to plug it in for all of our A's. Now, this last one, we actually wouldn't have to do it because we know, but that is going to give us 2, but I just went ahead and wrote it. Okay. So that's the equation. All right, and then if you wanted to use our graphing calculator to check, we can type that in. Now we already know it's going to have the right y-intercept. We'll just make sure it has the right x-intercepts. So our y-intercept is at 2, like we already knew it was going to be. And then our x-intercepts are at negative 3 and at 1. So we have the right function. Okay. All right, so this one is a little different. So that one we knew the x-intercept, so we used that form. This one we know the vertex, and so we're going to use the vertex form. All right, so this y-intercept is going to be a point that's on the graph. So we can think of it as a y-intercept, or we can think of it as it passes through that point. So that is going to be an x and a y. So what I would do now is take that negative 4 and put it in for y. Oops. Take that 0 and put it in for x. And then what we need to do is solve it for a. All right, so I'm just going to go ahead and add that 2. All right, and 0 minus 4 is negative 4. And then when I square that, I'm going to get 16. And then finally, to solve for a, I'm going to get that as negative 1/8. Okay, so then I would take that negative 1/8 and put it in for my a. Okay. And then again, if we want to check it to make sure that it does work out, we can't see very much of it, but we can see that the vertex is right here at 4, negative 2, and then it crosses the y-axis right there. So it goes through the point 0, negative 4. Okay. All right, and this one doesn't look super great, but we're going to write the function for this graph. And so I can look at it and immediately tell my vertex is the point 3, negative 1. And I can tell it passes through a couple of points. It passes through 1, 1, and it also passes through 5, 1. But looking at it, I can't see any other points, so it might be slightly easier to use 1, 1 over 5, 1. All right, so we're going to do this just like the last one. Go ahead and put our vertex into the vertex form. All right, and then we would put 1 in for x and 1 in for y. And then we're going to solve it for a by adding 1. Go ahead and subtract those. Square negative 2. Divide. So we're going to get that a is 1/2. And then I can take it and put it in for that a. Alright. And then one more time, we can just double check that graph we end up with matches what's here. We might not be able to see the whole thing the way my window. Oh, it's pretty good. Great. So that looks pretty good. Okay. All right, and then finally, we have an application problem. So for example 5, the height in feet of a ball thrown in the air is given by that function h of x, where x is the horizontal distance in feet from the point at which the ball is thrown. So what we get for y is the height at whatever the horizontal distance is from where the ball is thrown. All right, so we want to find how high the ball is when it is thrown. So like when the person is holding it in their hand, so that's basically going to be the when x is 0 or the y-intercept. So we can just look at it because it's in standard form and tell that answer. So that's going to be 3 feet. All right, and then we have the maximum height of the ball. So the maximum height of the ball, we need to find the vertex. So that's going to take some work, and that's what we learned in the previous lesson. So what we would do is first put the x terms in parentheses, then factor out the coefficient of x. Now this gets kind of tricky. So if we're factoring out, we're basically dividing. And when you divide by a fraction, so we're going to have to do 6 divided by negative 1/12. That's the same as multiplying by the reciprocal. So that's going to be negative 72x plus 3. All right. And then to write it in vertex form, we're going to add on the inside. It's going to be a pretty big number. And then we are going to subtract on the outside. And whatever we subtract on the outside has to get multiplied by negative 1/12. Okay, so we have to take half of 72, which is 36, and then square it. And so I had to type it in. So our little calculators, you can just do 36 times 36, but that's going to be 1,296. Okay, we're almost done. So we're going to do negative 1/12, and then in factored form, it's x minus, and then what we got when we took half of 72. All right, and then because I have minus, we can do plus a positive, And then if I do 1/12 of 1,296, that's 108. And then plus 3 is 111. Right? So our whole vertex is the point 36, 111. But we want to know the maximum height. So we have to decide which one of those we would use. And so the function the y equals the height. So in this case, we would want to use the y. Now, if the question was, what is the horizontal distance from where the ball was thrown when it reaches the maximum height, we would use the 36. But if we want the actual height, in this case, we would use 111, only the y coordinate. All right, and then see, how far from the thrower does the ball strike the ground? So if we're looking for where something strikes the ground, we are looking for an X-intercept. So the X-intercepts are found when you take the function, and we'll go ahead and use the one that we put in Vertex Form and set it equal to 0 and solve it for X. All right. So instead of dividing by negative 1/12, I'm just going to multiply by the reciprocal. Okay, and then I am just going to round this to 3 decimal places. Okay, and then finally, I would just need to add 36. All right, so if I add 36 to the positive version, it's going to be 72.497 feet. If I add it to the negative version, it's going to give me negative feet. So it's like the ball hit the ground before it was thrown, which doesn't make sense. So in this case, the negative square root doesn't make sense. So we would only do the positive square root. All right, so your assignment is from the online book on page 177 to 178, number 6, 18 through 26 even, and number 30.